Today, we're diving into the crucial topic of web application security to understand how we protect our online systems. Our goal is to learn how to effectively protect your online presence from a wide array of ever-evolving digital threats. Let's explore the OWASP Top 10, a fundamental guide for understanding the most critical web application security risks. The OWASP Top 10 is a crucial guide, helping developers and security experts prioritize defenses against critical web application risks. Now, let's examine the core web application risks, focusing on the most prevalent vulnerabilities that exist today. It's essential to understand these critical vulnerabilities to effectively build secure and robust web applications. First, we'll discuss injection attacks, a common and dangerous vulnerability in web applications. Here, attackers send untrusted data, tricking the application into executing unintended and malicious commands. Next up is broken authentication, which compromises user identity and access control mechanisms. Weak session management often allows attackers to steal identities, gaining unauthorized access to user accounts. Then we have sensitive data exposure, where private information isn't adequately protected. This occurs when sensitive private information lacks proper encryption and protection, making it vulnerable. Another critical risk is broken access control, allowing users to perform unauthorized actions. Essentially, users can act outside their intended permissions, accessing or modifying restricted resources. Finally, security misconfiguration highlights the dangers of insecure default settings or ad hoc setups. This involves insecure default settings or custom configurations that inadvertently create security vulnerabilities. Let's delve into cross-site scripting, or XSS, a very common and impactful type of injection attack. XSS is an injection attack where malicious scripts are inserted into web pages, allowing attackers to hijack sessions or deface sites. Let's explore the different types of cross-site scripting, or XSS attacks, that we commonly encounter in web security. We'll delve into how these malicious scripts are cleverly delivered to unsuspecting users, causing security breaches. First up, we have stored XSS, often considered one of the most dangerous types of attacks. Here, the malicious script is permanently saved directly onto the target server, ready to be served. It then executes automatically whenever any user visits the compromised web page, affecting many users. Next, let's look at reflected XSS, which is a very common type of attack. In this case, the script is reflected off a web server as part of its response to a user's request. It executes when a user clicks a malicious link or submits a specially crafted form, tricking them into running it. Finally, we have DOM-based XSS, a client-side vulnerability that directly manipulates the browser's document object model. The key here is that the vulnerability lies within the client-side code, not on the server side itself. The script directly modifies the page's document object model, or DOM, right within the user's web browser. Now, let's move on to understanding another critical web security threat: SQL injection, commonly known as SQLI. SQL injection is an attack where malicious SQL code is executed on a database due to improper input validation, allowing data manipulation. Now that we understand these attacks, let's explore essential defense strategies against XSS and SQLI. These are crucial strategies for building robust web application security and protecting your users effectively. Let's first discuss the key defensive measures specifically tailored for preventing XSS attacks. Always validate all user inputs rigorously, removing any potentially malicious script tags before processing them. Also, encode all output to escape characters that could be interpreted as executable code by the browser. Furthermore, implement a content security policy, or CSP, to restrict script sources and enhance security. Now, let's shift our focus to effective defense mechanisms for preventing SQL injection attacks. Crucially, always use parameterized queries or prepared statements to separate code from data input. Additionally, validate and sanitize all user inputs rigorously, filtering out any potentially malicious characters. Finally, Apply the principle of least privilege for database access, limiting what users can do. Let's now explore HTTP security headers, which play a vital role in directing browser behavior for enhanced safety. These headers are essential for instructing web browsers on how to handle content securely, preventing common attacks. First, we have CSP, which stands for Content Security Policy, a powerful defense mechanism. CSP, or Content Security Policy, provides an additional layer of security against various client-side attacks. It restricts resource loading sources, significantly mitigating the risk of cross-site scripting or XSS attacks. Next up is HSTS, which stands for HTTP Strict Transport Security, a crucial header. HSTS, or Strict Transport Security, ensures that all communications between the browser and server are encrypted. It forces browsers to always use HTTPS, effectively preventing man-in-the-middle attacks and ensuring secure connections. Then we have X-frame options, an important header for controlling how your web page can be framed. This header controls whether your web page can be displayed within a frame, iframe, or object tag. By controlling framing, it effectively prevents clickjacking attacks, where users are tricked into clicking hidden elements. Finally, let's discuss X-content type options, a header that helps prevent MIME type sniffing vulnerabilities. This header prevents browsers from sniffing the content type, forcing them to use the declared content type. It ensures the correct file interpretation by the browser, reducing the risk of malicious file execution. Let's discuss how we can fortify cookies to ensure robust session security and protect sensitive user data effectively. We'll explore the key attributes you can set on cookies to significantly enhance their security and safeguard user information. First, the secure attribute ensures that cookies are only ever transmitted over encrypted HTTPS connections, preventing eavesdropping. This crucial attribute guarantees your cookies are exclusively sent via secure HTTPS, preventing them from being intercepted on insecure channels. Next, the HTTP-only attribute is vital for preventing client-side scripts, like JavaScript, from accessing the cookie. By setting HTTP-only, you effectively block JavaScript from reading or manipulating the cookie, mitigating many XSS attacks. The same site attribute helps protect against cross-site request forgery, CSRF, by controlling how cookies are sent with cross-site requests. This attribute restricts cookie transmission during cross-site requests, significantly reducing the risk of unauthorized actions initiated by other sites. Finally, MaxAge or expires attributes are used to control how long a cookie remains valid and stored by the browser. These attributes precisely define the cookie's lifespan, ensuring it doesn't persist longer than necessary, enhancing security. Now, let's delve into the WAF protection cycle, understanding how a web application firewall works in practice. This cycle involves continuously monitoring, filtering, and effectively blocking malicious traffic before it reaches your web applications. The first step is request inspection, where the WAF thoroughly examines every incoming web request for suspicious patterns. A WAF intercepts all web requests, carefully scrutinizing their content to detect any potential indicators of malicious activity or threats. Following inspection, we move to rule matching, where the WAF compares requests against its predefined security rules. The WAF meticulously compares requests to its security rules and attack signatures, identifying potential threats and vulnerabilities automatically. Next is decision-making, where the WAF determines the appropriate action based on its analysis and rule matching. After inspection and rule matching, the WAF decides to permit, block, or challenge the request, like using a CAPTCHA. Finally, we have logging and alerting, where all WAF actions are recorded, and administrators are notified of incidents. Every WAF action is meticulously logged, and administrators receive alerts for any potential security incidents, ensuring timely response. Let's quickly summarize the key concepts we've covered in our discussion on web application security. Here are the essential takeaways you should remember to strengthen your understanding of web application security principles. Remember, the OWASP Top 10 provides a crucial list of the most critical web application vulnerabilities to address. Cross-site scripting and SQL injection are prevalent and highly impactful types of injection attacks you must defend against. Implementing security headers like Content Security Policy and HSDS significantly boosts your browser's defense mechanisms. Utilizing secure cookie attributes like HTTP only, secure, and same site is crucial for protecting user sessions effectively. Web application firewalls, or WAF, are essential tools for filtering malicious traffic at the application layer. Always remember that continuous vigilance and proper security implementation are absolutely vital for robust web application security.